Okay, so I'm going to try to cover two concepts today within less than an hour. So again, we're starting a new unit on analytical geometry, which is doing a lot of stuff with points and things that are Cartesian plane. Okay, so just go through the handle together. So 1A, we're simulating two telephone towers. Okay, and we're going to map these towers in our Cartesian plane. So here we have our x-axis. And our y-axis. So in this first example, we have tower 1. It's located at the origin. And we have tower 2 is 0, 10. So there's 2, 4, 6, 8, 10. Takes us to the top. Okay. So the question is, we want to locate or put another tower in between those two. So where's the midpoint of this segment? So we always treat our two telephone towers here as like a segment. Where's the middle of that segment? What's the coordinates, or where's the middle of that segment? Rob?
0, 5.
0, 5. You got that pretty quick. So 0, 5 puts us right over here. How did you see that so quickly?
Just the middle of the line. The middle of the.
But how'd you know it's 5 though? Did you like count up?
Simple math.
You divided what by 2? How high it was?
Yeah.
Okay. Because we know it's a vertical line, right? So we just want to find the middle. Just take it divided by 2. Here we just took 10 because we know the origin was 0. We just took 10 divided by 2. We got 0, 5. Okay. So it's kind of an easy example. How about the second one? We have 2, 4, which gets us to 2, 4 over here, and 8, 4, which is roughly around right there. So there we have two towers over here. How do we find the midpoint of that segment? How do we get the midpoint of that segment? Oh.
4, 4.
Okay, how did you get 4, 4?
Because I know 8 divided by 2 is 4.
So 8 divided by 2 is 4. So if I go 2, 4, it gives me right here. So it looks like it's in the middle?
No, 4, 4.
Okay, sorry, 4, 4.
Yeah.
That's right there.
Oh.
Does that look like it's in the middle though?
5,
No.
Was it really? He says 5, 4? And how did you get that, Demetrius?
There's only 3.
Well, it looks like it's more in the middle. Right, so here's 5, 4, and that looks like it's more like in the middle. But why is it not 4, we did the same thing we did before, right? So all Mo did was she took her x coordinate this time because it's a horizontal line, and the furthest one away was 8. So she took that divided by 2. Makes sense that should be Demetrius?
There's 3, like for me, there's 3 blocks. If you divide that by 2, there's 1.5. It's 1.5. So if you go 1.5 towards the middle, it's in the middle.
You got 3 blocks? From here to here is 3?
Like on my sheet.
Yeah, if you did it by 2.
Oh, you counted by 2.
So
Okay.
there's 3.
So here I counted by 1, so there's 6, right?
Then you go 3 blocks.
So I go 3 blocks back. So that kind of makes sense. So I counted, this was 6, it went 3 blocks back.
I figured I did in the first one, just add 0 plus 10 divided by 2, so I figured you can still have the coordinates divided by 2 equals 5.
Okay, so that's another way of looking at it is, we didn't start exactly from 0 here, right, Mo?
Yeah, that's what it was.
So we were kind of 2 off, right? So instead of starting 8, we just went 8 minus 2 because we're 2 away from the start, and took that divided by 2. Which, what was 8 minus 2 though? Which gives us what? Really the length that Demetrius got. So here, the midpoint of that was 5, 4. Okay? Dan, you'll be writing down these examples. Let's move along, please. had 8, 2. So that's 8, 2 is here is one tower, and 10, 2 is another tower here. So this one's kind of relatively easy. Where's the midpoint of that segment? 9, 2. Right? So here is 9, 2. So question part B says, well, study the points. How do the y coordinates relate to tower 1, tower 2? And how do the x coordinates relate? That's part C. So how do our x and y coordinates relate to one another? So in this first example, how did the y coordinates relate? So we had 0 and 10, or a new point was 0, 5. Y coordinate is 5. What's the relationship there? It's in between the two y coordinates. So really this is, the first one is 10 plus 0. Let me go the other way. 0 plus 10 divided by 2, and that gives us 5. What about the second example? What's our y coordinates there? 4 and 4, they're the same, so I mean, not much exciting over there. But if we try to do the same thing, well, what's 4 plus 4 divided by 2? Do we still get 4?
Yeah.
And what about the last one? Last one is the same thing, 2 plus 2 over 2 still gives us 2, right? Because the last two, they're horizontal, the y doesn't change, right? If it's a horizontal line, the midpoint is still going to be that same y coordinate. How about the x coordinate on this one? Well, there's no difference here, so it's still 0. What about the second one? What's the relationship between the x coordinates of the original points and the x coordinate of our midpoint? We sort of touched on it already. Yeah, we add them together. So here's 2 plus 8 divided by 2. I should put these in brackets really. And that gives me 5. The second one, 8 plus 10 divided by 2. That gives me 18 divided by 2, which is 9. Okay? So that kind of makes sense with horizontal and vertical lines. Any questions on that? Okay.
Wait, for C, what were you doing there? I didn't understand that.
For C, so C we're looking at the x coordinates.
Right.
So I was looking at the x coordinates here and how we relate it to the midpoints.
So you did the same thing.
So I was doing the same thing with the x coordinates.
So 0 plus 0 divided by.
I went back to the first example. We did 0 plus 0 gives me 0, divided by 2 still gives me 0. So that still kind of works.
Okay.
This one?
What does that second line say for C?
2 plus 8
No, that's not.
divided by 2.
It's one under that.
8 plus 10. Because our first coordinate was 8, second coordinate is 10.
Yep.
So we just add them together. Okay, I don't want to do that question. More. So let's say we had 200 cell phone towers. 2, 1, and 6, 9. So let's graph those. 2, 1 is roughly around here. And 6, 9, 2, 4, 6, 9's up here. So this is the distance between our two other cell phone towers. How do we find the midpoint of that? It's no longer horizontal, it's no longer vertical. Gives a little bit of a challenge. How can we find the midpoint of that? We can find the slope. How's that going to help us find the midpoint though? Good idea. We could get the slope. But slope relates to a whole line. Doesn't help us with the beginning ends though, right? Well,
You could do what we did for B and C. You could take the x coordinates and do 2 plus 6 divided by 2 to get the x axis.
okay. So let's do that first. So what's 6 plus 2 divided by 2?
4.
So 6 plus 2, I'm going to do this over here. 6 plus 2 divided by 2 is 8 over 2, which equals 4. So I'll go 2, 4 is right here. So roughly it's going to be somewhere along here. Right? So there's an x equals 4. And it looks like between this point and this point horizontally, that does look like it's in the middle. At least horizontally. Right? So we took this endpoint, this endpoint, sort of found the middle horizontally. What about vertically? Caitlin? No? Demetrius? How about vertical now?
Oh, you can add the two y values and divide by 2.
Yeah, so here we're going to add 1 plus 9 divided by 2. That gives me 10 over 2, which is 5. So vertically 5 is roughly around right here. So I'll find where those two intersect. Does that look like the midpoint? Okay. So that's what it really is. 4 comma 5. Okay, so let's generalize. Okay, so in general, how can we discover the midpoint? We're given 2 points. So a segment with 2 points, how can we discover the midpoint? Jamie?
If you did x1 plus x2 divided by 2, you get the midpoint, the x values for the midpoint, and then y1 plus y2 divided by 2, you get the...
So x1 plus x2 divided by 2, you said? And then y1 plus y2 over 2. We need the brackets because it's still a coordinated pair. Right? This is an x value, this is a y value. So we denote the midpoint with a capital M. Okay? So this is how we calculate a midpoint of a segment once we know its ends.
x1.
x1 plus x2 divided by 2 over y, comma y1 plus y2 over 2. Okay, so next page, a simple question. Right, so we have the coordinate, we want the coordinates of the midpoint, the line segment that's formed by endpoints here. So how we go off and calculate this? What's our formula?
x1 plus x2 divided by 2.
So here, does it matter the order? Which was x1, y1? No, right, because we're adding, right, so it really doesn't matter the order. So here, x1, I just choose as 5 plus negative 12 over 2, comma, 1 plus negative 3 over 2. So that gives me 5 plus negative 12 gives me negative 7 over 2. 1 plus negative 3 gives me negative 2 over 2. So midpoint is equal to minus 7 over 2, comma, negative 1.
Can you say a negative 3.5 if that's easier for you to visualize on the...
Sure. But we like working with fractions because we're going to do stuff with this later on.
Oh,
So try to keep your answers in fractions.
So
Okay.
don't ever put it
No, because it's naturally going to be a fraction anyway, something over 2. So just leave it.
But what if it's like negative 2 over 2, you have to add it?
Yeah, so we need to simplify it. So if it's like negative 4 over 2 or 4 over 2, you want to simplify that to 2. So if it divides evenly by 2, we want that integer. Any questions? So you could try number 2. Ooh, number 2 is hard. Let's not do that by yourselves.
you have to rearrange the exponent.
You have to rearrange the formula. What are you talking about?
Well, you wanna isolate, HTS, one of the variables. I don't know how you do it.
Yeah. So this one's a little bit different. We're given the midpoint of 2 points of a line segment. We need to find the other end. So here's the midpoint. This is the midpoint. And we have an endpoint here. So we need to find the other end. So we just graph this. We got, oh, my grid looks really bad. 10, 2. So that's one endpoint. And 8, 5. Be roughly somewhere around here. So that's the middle. So roughly, where's the other end have to be? So we're up here, right? We can measure, but we're going to do this by math. So our midpoint formula again is x1 plus x2 over 2, comma y1 plus y2 over 2. This time, do we know the midpoint?
Yeah.
So what is it? Yeah, so it's 8, 5 is equal to, well, I'm going to choose this as my x1, y1. So do I know my x1?
Yes.
Yeah, it's 10. Do I know my x2?
No.
No. Do the same thing with y1. My y1 here is 2 plus y over 2. So now here I'm just solving for two equations. This x must equal to that, and this y coordinate must equal to this y coordinate over here. So we have 8 is equal to 10 plus x2 over 2. So that's one equation we need to solve, and the other one is 5 is equal to 2 plus y over 2 over 2. Damn. Is there a reason why you're writing this? Okay. Don't say anything. Ask you to do it though. So we're going to solve for it. So solve for the left side. How do I solve for x2? Okay. Good. Multiply both sides by 2. So I get 8 times 2 is equal to 10 plus x2. So I'll just simplify the left side. 16 is equal to 10 plus x2. Then multiply.
Then you subtract 10 by both sides.
Good. So here I get 16 minus 10. So x2. So x2 is equal to 6. Do likewise on the right. Multiply both sides by 2, so I can get it's equal to 2 plus y over 2. And then I can subtract 2 from both sides, so I'll get 10 minus 2 to y2. So that's 8 is equal to y2.
What you multiply? What's the first part? You multiplied
I multiply both
By
sides by 2.
2.
So
to
same
get
thing
rid
that
of the
we.
bottom.
Yeah.
And then you divided. You subtracted 10.
Then I subtracted 2 to isolate for y2. So 10 minus
No,
2.
I'm
We talk about the blue or the black?
black.
Oh, the black.
Yeah.
Yeah, so then I subtracted 10 from both sides. Because the one
So
x2 by itself.
why do you leave it as 6 equals x squared?
No, it's x2.
Oh, x2. Oh, because then you know your point.
Because, yeah, I'm looking for x1 and x2 and y2 here. So therefore, the other endpoint is 6, 8. So if I actually plot it, it'll look like it's somewhere over here. And that looks about right. Okay? So that's how you could go the other way, finding the other endpoint if you give an endpoint in the midpoint.